Hello and welcome back to CS128 Honors. In this video, we'll be talking about mutability. However, fun story, this was actually recorded earlier this summer, back when some of our branding and other stuff was actually different. So for the rest of these slides, you'll be noticing a little bit of a different color scheme and other things, as well as a bunch of outdoor noises, because this was when I was elsewhere outside of campus. So hopefully you enjoy the change of pace and scenery, but otherwise we'll return to it for the next lesson video.
So how do variables work? Well, in Java we have our simple main function here that's creating a variable and then printing out. Let's take a look at how we do that in Rust. So you'll notice here that Rust is a little bit shorter, right? On our first line, as opposed to public static void main string args, all we have to do is fn main, function main. Then on our second line, we declare the variable. So as opposed to saying int x equals 0, where we say a strong type, we just say let x equal to 0, and Rust is able to infer automatically for us that x is an integer because 0 is an integer, and that's what x has been set to. Then we print it out by saying print line exclamation mark, and then we pass in a string with some brackets and then the variable. So what this print line exclamation mark is doing is it's saying, okay, where are these curly braces? It finds them and then it replaces them with the value of the variable. And what this is really nice for is if you have a lot of variables and a really long string, it makes it a little bit easier to read than if you were looking at the system.out.println where you have a bunch of pluses everywhere then. And for some extra content, if you want to know why the print line has that exclamation mark, take a look at the link at the bottom right corner there. And so when we run both of these functions, you'll see that both of them are equal to 0, which is exactly what we expect. So now let's take a look at adding 1 to each variable. So on the left, this is probably pretty familiar to you. You're going to say x equal to x plus 1. It'll print out 1. You're all good. However, in Rust, this is actually not going to work. It's going to give a compiler error. And it's going to give us this error, cannot assign twice to a mutable variable x. And so let's talk a little bit about mutability in Rust and variables in general in Rust. So, what is variable and why are we talking about them again at such a low level? Well, the reason is because in AP Computer Science or CS124, how exactly variables work under the hood is probably not explained. And that's because in Java, you don't really have to worry about it. It'll handle it for you. Whereas in Rust, you're working a little bit closer to the memory and you're going to need to worry about it yourself. So the reason this doesn't work is because Rust favors concurrency, and in order to understand why, we have to take a look at how variables work. So here's an example piece of computer memory. You don't really need to worry about the binary or anything else, but just know that there's a bunch of binary bits somewhere out there in the computer. And so when we say x equals something, it marks off a certain part of that memory and says, this is x now. And what Rust can do now is it says, okay, this is now it, and we are not going to change anything inside x. And this way, if we have multiple threads and a bunch of other things going on, it will never change, which means that it's safe. However, we sometimes don't want that, right? Sometimes we want to be able to change things. And for that, we have the mute keyword. And so what this mute keyword will do is it'll say, don't worry, we understand what can happen with variables, and we're going to watch out for it, and we want to be able to change it. And Rust will say, okay, go ahead, this is now, you're responsible for it. And so now x can be changed, and this will print out x equal to 1. So let's talk about mutability. Rust heavily favors concurrency, but only if it's done safely. In order to encourage writing safe concurrent code, variables are immutable by default to prevent race conditions and many other situations that you'll run into later this semester when we talk about concurrency. However, in some situations, or even many situations, especially early on, you want mutable variables. You want to be able to change them. And so in those cases, we have the mute keyword, MUT. And the mute keyword is short for mutable, which means that variables can be changed. And variables marked mute can be modified after their declaration. And so the downside to this is that it's easier to make mistakes when writing concurrent code. And this is a really big point that we'll come back to when we get to our section on concurrency. So let's talk about shadowing. Shadowing is a safer version of the mute keyword. And so it allows us to achieve the similar behavior without some of the riskiness with the mute keyword. And so shadowing is the practice of creating a variable with the same name. And so this would be like saying let x equals something after already having declared x. Now you might be wondering, in most languages, this is prohibited, right? Why isn't this prohibited in Rust? It's because of concurrency safety, and it allows us to bend the rules a little bit. And so doing this in Rust tells the compiler to ignore the previous variable's value and to use the new one instead. So taking a look at this example, we have function main once again, and we say let x equal 0. But then we say let x now equal x plus 1. So it gets the 0 from the previous x, it adds 1 to it, and then it creates a new variable called x, and it forgets about the old variable x. However, the old variable x is still out there if we were using concurrent code, so we're able to be thread safe. And then finally we print out, and in this case we get x equal to 1. Now one thing to note here is that if we put x equals mat as string, which is not what we were thinking when we initially wrote this, we'll actually get x equal to mat. So be aware that shadowing is in essence declaring a new variable. And it means that you can accidentally, if you're not careful, change the type of the variable to something that you don't want. So in summary, variables can be declared with the let keyword. This is very nice because it allows us to not focus on the types and let Rust infer what type we're looking for. Then variables can be used elsewhere in the program just like any other programming language, and variables are immutable by default, meaning that their value cannot be changed. However, if we need it to be changed, we can use the mute keyword to make them changeable. Beware that doing so introduces the possibility of bugs when working with concurrent code though. And another option is to use shadowing of immutable variables to achieve a similar effect to the mute keyword without some of the dangerous behavior that can happen with concurrent code. And be aware with that doing so means that you have to be very careful about the types of your variable assignments and you're actually setting them to be what you want. So yeah, that was variables and mutability in Rust. Check in for the next video for basic types in Rust.